Okay, so we're on this one we're going to prove that the derivative of secant x is secant x tangent x. I'm assuming that you've already watched the video on cosine, and if that's the case, then you only really need to know one more background piece of information here, which I think probably most of you guys already know, and that is the fact that secant x is equal to 1 over cosine x. I think that if you know that and you watched the video on cosine, you guys should be pretty good to go. So let's go ahead and begin. The limit as delta x approaches 0 of secant x plus delta x minus secant x over delta x is the derivative of secant, right? Now what I'm going to do is I'm going to rewrite the secants as cosines instead, but since secant is the reciprocal of cosine, it's going to look like the following. And just like we did in the last video when we had a complex fraction, we're going to clear these denominators by multiplying everything by the denominators. So let's go ahead and do that. So the first thing I'm going to do is I'm going to multiply everything by this denominator here, cosecant x plus delta x. If I do that here, then I'm going to be left with a 1 in that spot, minus, and if I do that here to this piece, I'm going to have a cosine of x plus delta x over cosine x. And then if I do it on the bottom, I would have the following on the bottom. Okay, I'm going to repeat that process for the other denominator now. I'm going to multiply everything by cosine of x. So if I multiply this piece here by cosine of x, the bottom cancels, and I'm left with cosine of x plus delta x there, minus if I multiply this piece here by cosine of x, I'm just left with cosine of x. And if I multiply the bottom by a cosine of x, I would have everything I had originally, as well as a cosine of x. Okay, so I've cleared out the complex fraction there a little bit. Okay, well now I'm going to use the same identity that we used in our cosine proof video. So cosine of x plus delta x can be rewritten using the identity for angle sum with cosine. See what that would look like. Bring down the cosine x minus. Now in brackets here, I'm going to put what this portion is. Bottom stays the same. Okay. Now this subtraction sign here applies to everything, so this is going to become a negative cosine here, and then this is going to become a plus because we're distributing a negative. Okay. What I'm going to do then on the next step is I'm going to, let's go ahead and group these two portions together, and we'll kind of group this separately. So this step isn't, necessary for the proof necessarily, but just for helping it make sense as I go. I want you guys to be able to see it clearly. So I'm going to go ahead and do that. So matter of fact, I'll do something useful here. So here I've got those two parts that I circled on the top there. grouped. Right? And I'm going to put them over that denominator. And then I'm going to split the fraction up with the other piece. So this sine x over here, I'm going to put it in its own little fraction because we have to do that anyway somewhere along the way. And this is a good time to do it. All right. So first of all, we're going to continue rewriting this a little bit. I'm going to start by factoring out this this cosine right here. Seeing a lot of common moves that keep coming up, right? Grouping and factoring and splitting. I'm also going to rearrange my denominators a little bit here. I'm going to put the delta x on this side, and I'm going to move these two pieces here over here. Totally legal with multiplication. The order doesn't matter. I'm just switching the terms around a little bit. Okay, but why would I want to do that? Well, we'll see in the next step. I think I'll do a similar thing over here. I think I'll move this sine of delta x to the front. Put the sine x over here instead. Put the delta x here, and then I'll put the cosine x and then cosine x plus delta x here. Okay, so first of all, on this side over here, notice that this cosine will cancel out with this cosine. That's one thing that we can pay attention to. I don't see anything else happening on the other side over there. So I think what I'm going to do at this point is I'm going to go ahead and apply my limit. I think we're ready to do that, believe it or not. Once again, if you watch the cosine and sine derivative videos, you'll see that this portion right here, we talked about that earlier, that becomes 0 whenever you put the limit in. But I still have, let me clear that. I still have a 1 over cosine of x here because I need to apply the 0 to that delta x, and so that delta x just goes away and I'm left with there's an imaginary 1 here, 1 over cosine of x, but it's being multiplied by 0, so that whole piece just goes away, right? So now whenever you guys do your proof, you don't have to show all this. You could just kind of like put a big x through the whole thing because that whole thing goes to 0 because this piece here equals 0. It just kind of makes everything cancel out. But we're not done yet because the limit also applies over here. We're going to apply it there, and we're also going to apply the limit there. Now this, we learned in a previous video, equals 1. And now on the bottom I have cosine x and cosine x, because x plus delta x, which is 0, is just going to leave me with x. So now I've got sine over cosine x, cosine x. The 1 can be ignored because anytime you multiply by 1, it doesn't really do anything. But I'm going to do something else a little bit weird here. I'm going to put sine over x, cosine x I mean, times 1 over cosine x. So I'm splitting up this fraction here so that the denominators are in two different spots. And the reason I want to do that is because those two pieces I just parceled out there are actually identities. You guys hopefully remember that sine over cosine is tangent x, and 1 over cosine of x is, as we said at the beginning, secant x. And there's our proof. So the derivative of secant x is secant x tangent x. I have them in backwards fashion here, so if you want to rewrite them, you're welcome to. It's the same thing either way. But there it is. So that's the proof for secant. Once again, I'm not going to do cosecant. The proof for it is very similar. Something that if you want to satisfy your math mind, you're definitely more than welcome to look that up. So let's move on to our next video.